So we are delighted to have today with us Dr. Cassandra Potier Watkins. Dr. Potier Watkins is a research scientist at the Collège de France, where she completed her PhD with Professor Stanislav Dehaene and continues collaborative work on the neuroscience of learning. Her research bridges foundational science and practice, investigating how the brain acquires reading and mathematical abilities while developing evidence-based interventions. As president of Excello, she leads a nonprofit distribution of open access research-tested educational methods to schools. She serves on France's Scientific Council for Education. Her work on visual orthographic processing and dyslexia builds on pioneering framework developed with Professor Naama Friedman at Tel Aviv University. So without further ado, I want to welcome you, Cassandra, to our Bar-Ilan University Vision Science Seminar to hear about your exciting research, and thanks so much for joining us today.
Thank you for having me, and thanks so much for making the effort to be here despite circumstances. Thank you to Sharon for your invitation to participate in this seminar series, which I watched a few of them on YouTube, and they were really excellent. So as it was already said, the main objective of my research is really trying to understand how the child's brain learns in school. I'm interested in education that happens in schools in general, whether that be reading or math, but my work really did start more in reading development. And I don't like working on just foundational work. I like to very much work in the applicable side too, because I think there's a lot of bridges that can be made between cognitive sciences and school. So a lot of my work today is also in this domain of how do we develop better methods for teaching children. And so with Professor Dehaene, we created a nonprofit called Excello, where we try and take a lot of the work that we do within our research lab. And then once we feel like we have something that we can share with the public, we distribute it through Excello. So Excello, you have the website here. Pretty much everything I'm going to show you today, be it some of the testing that we do for dyslexia or the reading methods that we're developing, you can find more information about these tools on our website. So today we're going to focus more on the visual system, since it seems like that's what this group is more about. As you all know, the visual system for most normal readers is the first entry point into reading. In fact, I think we can say that learning how to read for a normal reader is really training your visual system to access the language system which already has lots of words and lots of meaning into it. When you learn how to read, you're going to train that visual system to enter into this world of words and semantic and syntactic knowledge. So today we're going to speak a little bit about the different, first I'm going to start off with some of the different visual processing that's required within reading. And then we're going to speak about visual processing that can go wrong in dyslexia and those types of dyslexia that exist. And then, because Sharon told me I could, I'm going to share with you just some of the materials that we've been developing for teaching children how to read and show you where you can find them. And we are always open to translating to other languages and developing our methods for more and more countries. So if you can feel free to contact me if you're interested in going further and more of that applicable work that we do. So before I even really joined our lab was quite well known for the work it was doing in reading, be that through Professor Stanislav Dehaene or his wife, Ghislaine Dehaene-Lamberts. And one of their, I think some of the most important work they did was on the visual word form area. So this is really showing the importance of the visual and the emergence of the visual system in learning how to read. Because to be able to read is both something that is constrained by the visual system and that also changes the visual system. Up until you learn how to read, for most children, using your visual system is more about recognizing objects, recognizing people's faces, thanks to invariant identification. But when you learn how to read, you have the development of the visual word form area, which is a far different way of visually recognizing something than it is to recognize a face or to recognize an object or a house. So that's something that we're going to look at here. This is a typical paradigm for looking at the visual processing of different types of images. So we have people like children look at this type of task, and they have to tell us every time they see the star by pressing a little button in the fMRI machine. Of course, seeing the star is not what's important at all. It's just because we don't want them to fall asleep, so we try and give them a task. But what we can do here is we can try to parse apart the bombarding the visual system with pictures or with houses or with words and seeing what areas are important for recognizing these objects. So work that Ghislaine Van Lamberts did at our lab was this to show the development of the visual word form area in students. So they scanned 10 students who were learning how to read every 2 months, doing 2 fMRIs before they learned how to read, and then following them all through their first grade and into their second grade year. So the graph that we see here is basically the number of words that children read per 1 minute. Each line, each one of these different colors is a different child. And so we can see that, of course, every child learns to read better and better, more and more by the time that they're in second grade. But what's important for us today is that we can see that in this visual occipital region, we have the development of the visual word form area. So the green is areas that we're interested in words, the red is faces, yellow houses, the blue, the checkerboard. And we can see over here in this visual word form area that at about the end of first grade, it begins to appear, and then it becomes really strong when these children are 9 years old, after they are good readers. So the visual word form area is kind of like the brain's letterbox for written words. It appears during the first year of learning, and its activation also predicts children's reading scores. So there was a direct correlation between the number of words children were reading and how active this area of the brain was. And this is something that has also been measured by our lab where we can see a difference in this visual word form area between people that know how to read and adults that never learned how to read. So this study was done here with 6 groups of participants. We had Portuguese and Brazilian literates. So these are people that went to school, learned how to read when they were children. Portuguese and Brazilian ex-literates. So they didn't learn how to read in school, but they learned to read later on in life. And then populations of Brazilian illiterates. So you can see here on the bottom, the illiterates, when they're reading pseudo words. So these aren't real words because some of those things they might just recognize. But pseudo words, they're at 0. And we see gradual increase for each of these groups who are better and better readers. And then this is their reading speed and then their accuracy chart. And when you look at the visual word form area, you see the same thing that you were seeing before with the children. So the better they are at reading, the more active the activation is here in the occipital regions for vision sensitivity in the visual word form area. So these are just 2 really, I think, important and lovely studies to show us from our lab how important this visual area is, and that there is a visual area that's very specific for learning how to read and for the written word. But it's not the same thing as learning to recognize many other things. So the other pictures that we showed you were of houses, of people's faces, of tools. And we all know that when you see those types of objects, or when you see my face talking to you today, your visual system is invariant. If I turn to the left, if I turn to the right, I'm still Cassandra. I don't become all of a sudden a different person. Well, this is not the way it is for reading. So when you have this visual word form area that develops, it also has very distinct specificities that it has to develop in order to be able to read and, of course, write. So I think we've all seen children, they will do inversements of letters, writing backwards. And this is something that's very common when they're first learning how to read and write. And it's because this visual system sees mirror images as exactly the same thing. So these children aren't necessarily having troubles or dyslexic. It's part of the natural course of training the visual system to suppress this automatic mirror generalization, to be able to distinguish letters, distinguish their directionality, etc. So this is a very specific part of the visual system that has to be trained for reading that is different for other recognition specificities like in faces and in houses and tools. Reading also requires coordinated visual attention to process multiple letters in parallel. So at any time that we are reading, we're actually only looking at a space of about 8 letters total. And parallel processing means that the eyes take in multiple letters, and the brain must treat then which one goes with which word and what position each letter should find itself in within a word. Young readers have a very high number of fixations and longer fixation durations than older, more proficient readers. Probably this is based on the scale of how much time it takes for these younger readers to do that parallel processing. And they make a higher number of short forward saccades and make regressive saccades more often than adults. On the other hand, so that's kind of the different steps, just a couple, not of course, not all the visual steps that go into reading, but just a few different visual steps that I wanted to highlight that are very, very important for the brain to become a reading brain. But I also want to look at the other side. This is the teaching side of it. This emergence of these visual processes are not just the natural order of what's going to happen when you learn how to read. The way we train the visual system to pay attention also affects how the visual sensitivity to words will be structured. So, for example, in this article that was done by Yoncheva and Bruce McCandless, they decided to teach adults a new language to read in. So it was an alien language, they called it. And they either had participants focus on the whole world. So this would be, they would learn that this symbol here refers to man, or they had them learn it through grapheme phoneme teaching. So this is learning the letters and their sounds. So for example, they would learn that this shape was the sound, and this is the E, and this is the T. And they would learn each of those, and then they would learn it to be able to read it within the whole word. So training spanned about 2 consecutive days on this fake language, alternating 3 blocks per condition and 7 repetitions per word. So that meaning that everybody learned some words using a whole word focus and some of them using this grapheme phoneme mapping focus. Afterwards, they tested them, the students that completed this. So it was in a matching task where they would see the word in its whole system, and then they would hear it, and they would have to say if it was a correct match or not. In the GP condition, there was an extra transfer set. So not only did they see words that they had learned, but also new words that they had not learned, but that used the same letters that they had learned during their training period. And so if we first look at the reading words under the trained grapheme phoneme, we can see that it focused significantly more left lateralized. So this is in the same area as you would expect for the visual word form area. This is EEG, so it's less fine-grained than fMRI studies, but we know that this area is very similar to what you would what you were looking for in the visual word form area. So when they were trained with the grapheme phonemes and they look at those words that are grapheme phoneme matching, that elicits a left lateralized visual word form area activity. But when they would look at words that they learned as the whole word, so more as an object, then they would have right lateralization, which was much closer to object recognition than reading per se when you look at normal reading measures. When they're decoding the visual words that have not been explicitly trained by the task at hand, so when they're looking at new words, but that they could possibly decode, so these are the trained ones, we see that when they had this transfer, they even had more activity, as if they were putting more effort, more work into trying to decode visually these words that they had not learned during the training program. So I hope in just these few very short experiments that I'm presenting here, I just want to kind of exemplify about how important the visual system is to reading, how there's many different tasks, and that the activity of the visual system that we require to do during reading isn't the same as what we require in other object type of recognition or face recognition. It's its own special set of details that have lots of complexity to them. And now I'm going to switch to something else. So when I was learning, about reading as a student and the models of reading that exist and how do we understand reading in the brain, I didn't hear much about the visual system. Basically, I would hear about the dual root model of reading. So this was the model for learning how to read that was most widely accepted, I would say, in the world, and especially here in my studies here in France. And we would learn that reading was about two parallel pathways that are working. So you have either the lexical route. So this is very fast, fluent reading where you have immediate access to meaning. And this type of reading, whether you're reading a word that is 4 letters or 8 letters, you're going to access it just as fast. You're parallel processing all the letters at once. And then there's also the sublexical reading route. So this is where you're converting graph and phonemes. This is slow reading. This is decoding. This is the young child learning how to read. Or whenever, as an adult, you read a word that you're not familiar with, you can't immediately access its meaning. You have to slow down and read it letter by letter or grapheme phoneme by grapheme phoneme. And if during dyslexia, if you have a deficit in this lexical route, well, then you have become more dependent on the sublexical route. So you don't easily access fast, fluent reading, but you're going to read very slowly. And on the other hand, if you have a deficit in the sublexical route, then you can only read by lexical reading. So sorry, just to say that if you have a deficit here, you're going to call it surface dyslexia. And then if you have a deficit here, they would call it phonological dyslexia. And it meant that you had a very difficult time learning how to read, because usually learning how to read is through graph and phoneme conversion. And instead, you would have to learn by memorizing words. So when I was in school, that was the model that I was taught. And for the most part, I was also taught that phonological deficit, so a deficit in this area, was the locus of dyslexia. And that most tests that I used and that I learned to use in school and at the beginning part of my career tested this phonological deficit. It was really the prevailing idea. And I would say it was so much the prevailing idea that even Professor Duhan said it was the prevailing idea as of the origin for dyslexia and wrote about it in his book, Les Neurones de la Lecture, which highly, of course, influenced all of us here in France. But then, after he came out with this book, Nama Friedman and Ann Castles very boldly wrote an article saying that how could Professor Duhan talk about all these complexities in the reading brain and all these parallels, stages and steps that it takes to read, and then say that any problem reading must just have one origin? How could that even be possible? It doesn't make sense. Because if there's so many different stages, well, then a deficit could happen, of course, in any one of these stages, leading to a cascade of poor reading. Fortunately, Professor Duhan, he listened to Nama Friedman, and they became very good friends and started talking more about dyslexia. And Professor Duhan, I would say, invited Nama to work with us more on how we were testing reading. And Nama brought a whole new model, a much bigger, a much fuller model of reading to us. So, which included this time orthographic visual analysis and a real something that I had not seen before in my studies that were very focused on the central parts of looking at dyslexia as either coming from sublexical or lexical root. She introduced to us the idea that, well, reading starts visually, so there could also be dyslexias that start already from that point. So this was, I think, something that as soon as Stanislas heard it and myself, it made 100%, it seemed so obvious. It was 100% obvious to us that she was right and that we needed to open our minds a lot more to looking at different types of dyslexias. The other thing that she taught us was how important it is the types of ways that you're going to screen for dyslexia. So up until then, we were generally using tests that were looking at accuracy and response rate, response time on a certain type of test that often maybe it had single words that were irregular and pseudo words. And you would just look at how long it took the person to read that test and how many errors they made. And then if they had a problem reading words that were irregular, you would say they had surface dyslexia. And if they had a problem reading the pseudo words, you would say that they had a phonological sublexical problem with reading. But Nama, she brought to us this idea that that was, of course, not enough. You have to check what types of errors. You can't just assume that because they're making a problem on this test that it is one or the other types of dyslexia, but you need to create tests that look at all these different stages in the reading processes and also record the errors that the students make, not just their response time or their accuracy. So Professor Duhan was visiting Nama in Israel, enjoying the wonderful dessert, the Malabi dessert, which I've had the pleasure to have myself too when I visited Tel Aviv to work at Nama's lab. And they decided to name our test Malabi while they were enjoying their delicious dessert. And they started all of our work that we're doing really today on dyslexia by redesigning the types of tests that we use. So today, this test, it has a two-step process. So first of all, every word that you see in the test was really designed, every word or pseudo word or word pairs was designed to make another word if the reader is prone to making a certain error type. And then when we score these tests, we don't look at just accuracy or response time. We code the type of error that the student made. For the time that we have today, I'm just going to talk to you about two types of dyslexia in the visual system that we were able to record in the work that we've done with NAMA. So one of these are letter position dyslexia. So letter position dyslexia is a reading disorder in which the readers correctly identify the letters in a word but misplace their positions. So, which is very important because we have lots of words that if you change the letters around, it makes another word, like form can become from. It's believed that it results from a deficit in encoding letter position during the early stages of orthographic visual analysis. So this is an error that you could make when you're reading words or when you're reading, when you go into the sublexical route, if you're reading pseudo words. And errors typically occur when transposing letters creates another real word. So that's very important in the types of tests that NAMA helped us develop, is that if you're going to have words in your test, you want to include words that have the ability where you transpose some letters and it's going to make another word, like this example, form and from. Because if you don't have that, students who have lots of practice or who are looking for, of course, they want to do well in the test, so they're looking to read a good word, they might catch themselves before they make mistakes. Where if you have words that can be turned into another word, they don't necessarily catch themselves when they make the mistake. Another type of dyslexia in this visual processing area that I'm going to show to you today is also attentional dyslexia. So attentional dyslexia is a reading disorder where letters migrate between adjacent words while keeping their original position within the word. Reading, for example, cat hub as hat cub. So here the letters have changed from one word to the other. They stay in exactly the same position. And of course, they make a new word, so the person reading them might not notice that they made an error. Although this type of dyslexia was originally thought to be an attentional problem, it now is acknowledged that it can occur without general attention deficits, suggesting a specific letter-to-word binding impairment. So what does this look like in our Malabi test? If you look over here, if any of you can read French, you'll see that a lot of these words have little things that if you change, they can become another word. So for example, for letter position, if you have the word orge, then that can become ogre, mère can become Marie, sing can become singe. In our pseudo word test, you also have these types of errors that can be made. So many of these words, by changing several letters, will become another word. So from possible, you could get police, and parmi, you could have promis. For the attentional dyslexia, we look at tests with 2 word pairs. So in all of these word pairs, you can switch letters and will still make a word in the other word. So bisvaz can become visvaz, maupois can become paupois, etc., etc. Up until now, much of the work that had been done on looking for these different types of dyslexia. So I know that Nama can correct me. I think there's 19 dyslexias now that she spotted, but she can put in the chat how many there actually are that she has found. I always forget. I feel like there's always more and more. But in any case, in our area of work here in France, it's really been just focused on phonological types of dyslexia and surface dyslexia. And up until now, there had not been any data that had come out on these other types of attentional and letter position dyslexia, mainly because I would say that there wasn't the correct test. You didn't have the kinds of tests that we developed with NAMA to be able to actually find these types of dyslexia. So our first goal was to see if we could find these types of students in our population. To do that, we worked with a school called Suresnes. So this is a school here in Paris that works with children with developmental dyslexia. And the goal of this project was to test the Malaby screener to see if we could find selective types of dyslexia. So students that only had attentional or surface or phonological or graph and phoneme conversion or letter position type of dyslexia. And we tested 16 students in 6th and 7th grade who had previously been admitted to this school on the basis of them having dyslexia. Responses then were scored, so we did the test. And then, as I said before, very important in taking these tests is you have to score the types of responses the students make. So we usually start by phoneme encoding all the responses that were made by the students, and then seeing if there was another word. So if the word was form and the student said from, then this would be encoded as a letter position dyslexia because we could tell that 2 letters were swapped out. Dyslexic participants were chosen from readers demonstrating a selective error response greater than the norm found from a grade matched control group. And 7 students were identified for a possible selective deficit with 4 available for further tests. So it's those 4 that I'm going to show to you today that showed selective visual types of dyslexia. So 3 of them showed attentional dyslexia and 1 showed letter position dyslexia. To get an idea of what does that look like, these are our 3 students that showed attentional dyslexia. So for example, when reading litre vivre, they would read litre vitre. So here they transpose the T and replace the V. As you can see, and very important to this, is they always keep about the same position in where they're going to make the switch. This is a very important factor. It's not just about all the letters are scrambled. No, position encoding is intact. It is the word to letter binding that is not intact here. M armé became arm M, fera sera became fera sera. So this student, they made migration errors of letters that were 4.56 standard deviations from the mean in our normal readers. This student here, again, the same thing. You can see the types of errors are very clear in their attentional dyslexia. The student made a few less, so they were only 1.93 standard deviations from the mean. And at last, we have our third candidate who also, once again, they're very clear swaps of letters, and at this time being 4.46 standard deviations from the mean. Very importantly, in the fact that we were looking for specific deficit types, is that all other error types that we encoded by these tests were in the normal range. So they weren't making then also letter position errors or also graph and phoneme conversion errors. So our student that had letter position errors, so this was one student that we found. So for example, what this looks like is they read linge, they read ligne instead of linge, proche instead of porche. So each time you can see these letter swaps that happened. And this time they were about 2.5 standard deviations from the mean of our normal readers. And when they did the pseudo word test, they also did letter transpositions, and this time being at 3.9 standard deviations from the mean. So that's what we see here in their errors. Word pair errors were all in the normal range. They were not significantly different from normal readers. Afterwards, because we get so many researchers here in France that believe in the phonological deficit hypothesis, that this is the locus of dyslexia, and that use predominantly today tests that really test for phonological errors. They don't look at these other types of errors. We wanted to see if our students that we found using the dyslexia, using intentional, our students with attentional or with letter position errors also had phonological deficits. So we had them do very normal, traditional dyslexia screening tasks, which they had all done when they had first entered this school, probably because the school did do a test of dyslexia with them and it said that they were dyslexic. But the school, once they go into the school, they get lots of reading training. The school has on-site speech therapists. They have on-site, they have very small classrooms. Everything is done to really help all of the students, if they have dyslexia or dyspraxia or dyscalculia. So these students were very, very well trained in reading. They were getting the best possible treatment as possible. So if they still continue to be dyslexic, it really is that they are dyslexic. And when we had them do these normal screeners now for reading, none of them were considered dyslexic anymore. So if we look at the Alouette or pseudo word repetition, phoneme fusion or phoneme suppression. So the Alouette is a test that they do where they have to read a nonsense text, so text that doesn't make any sense and that has lots of very rare, unfamiliar words in it. So it's very close to reading pseudo words, which is the usual way that they test for phonological dyslexia. And so all these students were poor readers. So they had no problems actually on any of the pseudo word repetition or phoneme fusion suppression, so the language-based tasks. They scored in the low ranges for the Alouette, but none of them were considered dyslexic by the Alouette. So they would have had to be below the 25 percentile mark in order to be considered dyslexic for their group. So this was really interesting for us because here we could pinpoint 4 students for the first time in France that showed very specific deficits without being considered dyslexic in the traditional phonological tests that are used all over the country to expose dyslexia. The next step that we took is we wanted to see if there was a double disassociation in these participants' errors. So we created more tests that were more difficult, specifically to one type of dyslexia or another. So we designed a test for attentional dyslexia, which had 528 word pairs. And each of these 468 pairs that had at least one possible letter migration, that would make a new word, 160 pairs that did not have any migrable letters. We had pairs of words that always had the same number of letters, so between 5 and 7 letters, and words ranged in frequency between 0 and 8,000 per million. There was no difference in frequency between the migratable and the non-migratable words. And all pairs and their inverse were presented in the list. So if you had l'envoi, you would have, that should have been voix long instead. Or if you had l'envoi, you had l'envoi as well as their migratable pairs, vont-loi, l'envoi. So we had you had all conversions possible in the same exact test. That way we could see if it had more to do with moving to a more frequent word or a less frequent word, etc. We also designed a test then for letter position dyslexia, and this was with 406 single words, 304 words with a possible letter transposition, 102 words without an existing anagram. Words, again, had a length of about 4 to 7 letters, and their words ranged in frequency between 0 and 14,000 per million. No difference in frequency between transposable and non-transposable words, and each word and its anagram were also present in the list. So here are the results then for those tests. We looked at how many, we looked at all the types of errors that our 4 students made on both the attentional and the letter position dyslexic test. And you can see very clearly here that our 3 attentional dyslexias on the between word migrations that they made in the attentional dyslexia test, they were significantly higher than the letter position task. So, and then if we look on the other end, if we look at the letter position dyslexic, they made far less errors than our student who had letter position dyslexia made on that task. And in each time when we compare their migration errors with their transposition errors, we have a significant difference in their outcomes for each of the tests. We also tested control students, so these were normal readers. And these, if we look at the comparisons between the types of the migration errors made in attentional tests compared to the control, we can see that all 3 of our attentional students were significantly different, but our letter position acted like one of the control students when they had this task. And then vice versa, if we look at all of our students, how they did on the letter position task compared to the control group, we can see that for the 3 students that had the attentional dyslexia, they performed no different than a control student, where our letter position dyslexia student did. So this was very exciting. This was work I done in my PhD for showing the first cases of attentional and letter position dyslexia here in France. These were, as I said, with a little bit older kids, so they were just going into junior high students. We also decided to work with one of my PhD students, continue this work in dyslexia at the Seren School, to try and understand if there's these types of errors in dyslexia. Are these things that even the normal reader, when you're very young and you're learning how to read, are these the types of errors that you're also going to make as you're learning how to read, but then that slowly disappear? So we referred to that test before that was called the Alouette. My headphones are connecting to my telephone. So we looked at the Alouette test. So the Alouette, as I said before, claims to test for phonological dyslexia. It is very highly used here in France. And it claims to test for phonological dyslexia because it cannot be read for meaning, as it has many of these unfamiliar words. So children must carefully read and decode the text. Going to turn this. And we decided to mimic this format. So we took a test that generally says that it works on phonological dyslexia. And we decided to make a similar test, but where we would look at the types of errors the students made and to see if we could use the same format, but also find other types of dyslexia, whereas the Alouette is only looking at accuracy and response time. So just to give you an idea of what these kinds of tests look like, here you have the Alouette. So it's, if you read French, you can read it here. Otherwise, I gave it to Claude and asked it to do a quick English translation. We are on a strange planet, on the pond or in the woods, everywhere our gaze flows, time is flash. So we have words, the syntax is always correct, but the words don't make any sense put together. And there's even sometimes pseudo words in here that, of course, don't make any sense. And we had students from first, second, third, fourth, fifth grade read this task. They read the Alouette, and they also read ours. Now, very importantly, is different from the Alouette and ours. Just like in the Malaby task, we have words that can lead to letter position errors, attentional errors, many of the different types of dyslexias that were seen in that first model. So, for example, right here you have the word ovile, where if you change the L and the V, you could have the word olive. And our results, first off, showed, and this was encouraging for us, is that whether the students we have here on the y-axis, the Mariette, so that's what we called our new test because it was my PhD student, Marie, who designed the test. So the Mariette on the y-axis and our Alouette on the x-axis, And we can see that there was a very high correlation for each of the grades, both in reading speed and in accuracy on the test. But now, unlike with the Alouette, we could also look at what types of errors students were making. So we can see this, of course, we looked at all the different types of dyslexias, but I'm just going to show you for our purposes today, the types of visual errors that we notice. And here you can see we noted all letter position errors, all attentional errors, and then other types of visual errors. So these could have been neglect or, this were mostly neglect or switching letters that couldn't be linked to a letter position or an intentional word. And we can see the very relatively high number of these types of errors that could be made at an early reading. So this was only about 60 words that they were reading altogether, because first graders were just reading the first paragraph of the text because that was about all that they could read in the 3-minute time limit. And 5%, around 5% of the errors are already on letter position or attentional errors. And you see that it very quickly drops. And then as they become good readers, they're ranking very, very few. But what's really nice, and I think that we were able to show here, is that all of these types of processes that go into reading and that later can be attributed to dyslexia are things that also have to be refined and fine-tuned in the visual system, even for normal readers. And the dyslexic reader is the student for whom it takes much longer to fine-tune these objectives, or who are just unable to even do it. There's a lot of, I would say that maybe sometimes we don't get to communicate enough today about the different types of dyslexia, because there's also a lot of bad actors. Here in France, when we started talking, about more visual dyslexias or other types of dyslexias, you had companies that decided to also jump on this bandwagon. So here in France, there had been previous work that was done by Floch and Ropars, who claimed that dyslexia resulted in a retinal anomaly producing mirror images and the absence of a dominant eye, which could supposedly be corrected with high frequency flickering. And so companies that work in developing glasses or lights decided to create these tools. So flickering tools with using stroboscopic light or flickering glasses, either, I think so, here, I put it down. Oops, I didn't put the number of hertz. I think it was for the flickering in the lamp, it's about 100 hertz, 120 hertz. And for the glasses, they're going to flicker at 70 to 90 hertz. So this just means that there's a very unperceptible little light. So it goes from dark to light, and the person that's wearing them or that has the light turned on doesn't even notice that there's this flickering going on. And these companies that were selling these things said that it would cure 90% of dyslexias. And you only have to pay about 300 euros for any of these tools. So we were very, seeing how we were already open to the idea that there are different types of dyslexias, we thought, oh, well, this is very interesting. Let's check this out and let's research this. So we decided to purchase, oh, here we go. That's what I was looking for. Yes, so the frequency is about 70 to 90 hertz for the glasses, or 60 to 120 hertz for the lights. And we wrote an article, published an article on this, where we show that we had students read our Mariette test with certain types of errors. We coded those errors, looked at those errors, and also looked at the accuracy and response time, and whether or not for one person, they would redo different tests, whether or not they had the lights on or off, or the glasses on or off. They couldn't tell because it's so imperceptible. You have no idea what's going on. But it made absolutely no difference in the number of correct words that these students would read. We also looked at it in terms of certain types of dyslexia, more visual dyslexias, and we saw absolutely no difference in any of the types of errors that students were making if they use these types of tools that are reported to help different visual types of dyslexia. So be forewarned if you ever see these things in your countries, that we have published data on them and they don't help. And what was surprising was we even had students that were already using these tools that came into the lab and that we tested, and who claimed that the tools had helped them. But when we did the research, we were able to see that actually there was zero effect on their reading. I think we made the internal choice of not telling them because at least we were happy to see that some of these kids were happy to read when they put on their glasses or their lights. So maybe there's more of a placebo effect that it puts them in the right frame of mind to be able to want to read. There are a few ways that seem to help visual dyslexias. So this is work from Nama Friedman and a few other researchers. What might help letter position deficits is increased space in writing. What might help attentional dyslexias is creating windows to help block out any of the conflicting information that you might get from words around. And also increasing font size from 14 to 22 points, and now in several articles seems to help readers. If you want to read more about any of the work that I just showed you, you can look at our Dyslexias with an S, different articles. And of course, all of our articles are online at Excello or at our lab. If they aren't free online, you can get them from our website for free. Now I'm going to make a little bifurcation into some of the other work that we're doing with Professor Duhan to just help reading in general. So this is our nonprofit Excello that I mentioned at the beginning. We created it in 2022, and with the mission to really disseminate different evidence-based reading methods and also evidence-based methods to help for dyslexia in France, but also now it's become anywhere in the world. So our program is called Kalulu. And as you can see by the different flags down here, we're working with different countries. The method itself has wonderful lessons for teachers and a teacher guide to help them to understand what is the science of reading. This is, we've noticed, very, very important to help teachers understand why is it important to teach reading a certain way. Well, it's because there really is a science of reading that's very well documented, but that doesn't always trickle down into the classroom. We also created very easy printable books for students and teachers to use. And these are just some of our students in classrooms today that are now using the method. So this little girl is learning, just learning. And so you can see she's in a decoding phase, reading very slowly, decoding each grapheme phoneme by grapheme phoneme. And then over here, we have a young boy who's now entered into fluent reading where the words just seem to flow into his brain and out of a mouth, like we all, have the feeling that we read. We also work on the writing skills of the students. So whenever we do reading, we also do writing. This can be very important, especially for what I showed you early on about the invariant of the visual system. Your motor system is not invariant. If a ball is coming to me and I kick it from that way or kick it from the other way, I'm going to have a different reaction of what's going to happen. So sometimes when you're learning how to write, it can help amortize a bit this invariability with the mirror system by giving the brain another information about which direction the letter has to go and how to recognize it, and if writing is left to right or right to left. We've also developed many little games for the students to practice reading with their teachers. These are always, all of our games always follow the same progression, working on phonics with the students. So this is what I showed you from the Bruce McCandless research, that how you teach reading is also important for the development of phonology in the visual system. So we always teach on a phonics-based reading method. So they learn to match a letter to its sound and then decoding those letters and sounds. And we also have an application that anybody can download around the world. It's available online. If you're interested in seeing it, you can download it from the App Store, from Google Play, which is just a phonics-based reading app for students. So Kalulu started in France, and now we are testing it all around the world. We just tested last year with I think we were over 2,000 students in Brazil and almost 1,000 students in Colombia, with very positive results, working in areas of the country in very low socioeconomic status areas of the country. We're now testing, we just started tests in Argentina, where we've created a whole grassroots movement where we communicate about our reading methods on social networks. And I'm proud to say in Argentina, we have 60,000 followers on our local Argentinian Science of Reading Instagram, and we have about 80 schools that have signed up to be using our method this year, which just starts right now because their school year starts in March. So I want to say thank you to all the people that work here at our lab, for our wonderful team, which needs to be updated. Not everybody is on here. And thank you to you and all the people that make this, that help finance our work and make it possible. And if you want any more information, or if you want to see the articles, or you want to see the Kalula method, you can go to Excello Lab to see all of that. So thank you very much for your attention.
Thank you very much, Cassandra. This was such an interesting talk, and of course, really interesting work that you're also doing with the public. So first of all, I want to invite everybody to unmute yourself, and let's give Cassandra a big applaud.
And I didn't know Nama was coming. I wasn't doing all that to flatter. I only found out about 15 minutes before this that she was going to be here. So very happy to see her today.
Yeah, it was really a great talk, and I don't know, are you happy to take questions?
Yeah, of course.
Okay, great. So first of all, anybody who's interested, you're welcome to unmute yourself or raise your hand. I myself have a few questions, but I'll start with one. So you said, I saw that no, Excello or Calulo. I'm not sure which one.
Kalulu is the name of the reading method, and Excello is our foundation, because we have then a method we're developing for math right now and different things. So it's the holder of the Kalulu method.
So first of all, I think it's an amazing initiative, and I was wondering if you are on top of distributing it for the better good, if you're also collecting inputs from the teachers or people who are using it in order to basically have some, it could be, I don't know exactly what are the components, but it sounds like this could also be very interesting in acquiring knowledge and understanding of associations and dissociations between aspects. And again, I'm not a reading expert, but I know that there are languages which are much easier to read. Like, well, from people who learn them, they say that it's what you see is what you read, and there are languages which are completely not. And I was wondering if then you would be also able to compare the the results or the types of dyslexia that are evident in one language and in another, and if this has to do with the structure of the language itself. So this is one question, or even, I don't know, thought that I had. I have more.
Exactly that. The goal is to create, I would say, in kind of a feedback loop, a constant feedback loop, where we create materials, we test them, we see if there's changes to make, ideas from the teachers, and then we can make those changes and refeed it. And our method it's paper-based, like you can print it out yourself for nothing. So it's not like a publishing house where they're going to print a fancy book, and then if they want to redo anything, it's going to cost you $20 to buy the new book. Or the idea was to really make a very quick feedback loop in research publishing. And we do have some differences that are already apparent. So we just finished this big test between very similar socioeconomic groups in Colombia with Spanish, which is a very transparent orthography, and Brazilian Portuguese, which is far less transparent. It's more like at the same level as French. And so that we can see already huge differences in, even if both of our Kalulu groups did better than the control in a randomized control trial, we see that there's even a bigger advantage for the children in Spanish who are reading at a transparent orthography and are reading more words per minute than the students that were in Brazil. So those are little differences you can see in orthography. Next, this year with the Argentinian group, we're no longer doing randomized control trials because we feel like, okay, we're confident in the method, but we're doing A/B testing. So the teachers are getting A/B tests that they know more or less that they're getting. So they're getting all exactly the same method, but there are very small differences that they're going to have in the method. that we hope to see and measure if there's an effect of that. And that's something that those types of ideas we get a lot from teachers. So for example, we had teachers that were interested in doing that are in very poor areas and that said, I can't even afford to print a book for each of my kids myself. So what if we just had students working together in pairs and sharing books? So this is one of our A/B tests. Half of our schools are not getting one book per child, but they're getting shared books for the children. And then the other group, the B group, is getting one book per child. And we're going to be following them and seeing if there's any difference. So this is kind of an economical question almost. And in some ways, I almost think maybe we'll get better scores in the peer tutoring, the peer sharing, because maybe they'll work more together and encourage each other more. So that's the type of stuff that we're doing, that is ideas from the teachers. We also, and I hope to talk to Nama soon, we have a group of speech therapists that are there in Argentina that want to help us do an A/B test of different things that might help for dyslexia within our books. So they're already using our Kalulu method, but now we've been able to design Kalulu method with increased spacing, or something everybody wants to test is colors on the graph and phonemes. It's already kind of been done, but it's not, we're not sure. So those are things that we hope to do, where we would test people on the Malaby, see what type of dyslexia they have, and then see through A/B testing if we can find little differences of activities that can help other students. So yeah, all that we hope to make a part of our plan.
Wow, amazing. Okay, I have more questions. So one question, you were talking about the potential double association, which you actually showed in the two tests. Now, I don't remember exactly what the names were, but you said that it was in a school that basically um, um, has many kids who have reading difficulties. And I was wondering, because you showed the differences, first of all, between the three kids and the one kid, and then with respect to the if I understand correct, a bigger population of kids in the school. And I was also wondering whether you took all the kids that like the regular the group, and if you compared, if you did a correlation between their performances or errors in the one test versus another, because that could also be interesting to see whether there's no relationship between them, because if it's based on the same mechanism, regardless of the kids who have very, that are, that you, that were diagnosed or classified as really having specific dyslexias. But if it's the same mechanism, you expect the performance to be predictive of, like in one test and another test. And if not, if there's no correlation, then no predictability, then that's also another substantiation of the idea that these are dissociated types of deficits. Just a thought. I don't know if
Yeah,
you're
so the
following my
control,
logic.
we tested everybody that they told us was dyslexic. And for that project, we were looking for people that showed only one type of dyslexia. So we had many students that showed like they seemed to have maybe a vowel dyslexia and a letter position dyslexia. So those ones we didn't want to look, just for the kind of a proof of concept to the scientific community. It was about really specific types of dyslexia. So we put those, we report them in the article. So if you read it, we report all them, but they aren't the ones that we returned and looked at. The control students were not in the school. Those were normal readers from public school system of the same age that we compared them to.
Yeah.
So
Now, I'm
yeah.
just thinking it would be interesting to see. I mean, I hope there's not going to be a correlation between the performances, but it just exploratory I thought. Last thing I want to ask is about actual vision, because when you were talking, and I never thought about that, and again, it's not my expertise, but you mentioned that Nama, well, anyway, the letter position dyslexia sounds to me, when you described it, very similar to what you find in crowding effects, that the position, visual crowding in periphery, and I'm not talking about because reading is in the center, but you do have a lot of times you miss out on the target because you confuse them with the distractors, which are on the sides. And what if Nama says to increase the spacing? So that's also something that really assists in visual crowding. And I was wondering, uh, going back to vision, whether these kids, or at least some of them, are tested on their visual abilities, but not only visual acuity, which I assume is not an issue, but maybe looking at visual crowding or other aspects, which could be really interesting. I mean, maybe they have some issues that are even more generic than reading,
Yeah.
but it's manifested mainly in reading. Just a thought that
No,
reading
no, that's a very
deficits.
natural thought. That's a very natural thought. I know in the work of Nama already, she's shown that that's not the case, that you
Oh,
have
okay, okay.
disassociation. So these students that go into the school, they get tested on everything when they go in. I actually met with the director the other day, and we have goals of doing more of this whole dyslexia project and to do better testing because he's not very happy with how they do the visual testing or how they do corrections of visual testing. But the idea is that when you're, for example, we do with these students, I didn't show it here today, we also did number naming. So they would have, so it's very similar. It's also symbolic, and they're going to have like 4, 5, 6-digit numbers, and they have to name them. And here they don't show a problem with that. So it's not an invariant visual problem, but it's very specific to the needs, I think, of the visual word form area that, as we can see, is very different in its the way it treats words and the way it treats other visual objects. So I think that you can have a problem that's purely dyslexic in the visual system that has nothing to do with other things that you're doing because we don't see it in number reading for many of these students.
Interesting, very interesting. And I'll follow up on the publication because again, as I said, this is not my field of expertise. So Cassandra, thank you so much for joining us. It was such an interesting and important talk and initiative you're doing on top of the science. So thank you very much. And I'm sure people are going to be interested in viewing this despite the circumstances offline.
Yeah.
So thank you so much. And again,
Thank
great
you. Thank you for
talk.
having me.
Yeah,
We
we're
have to keep doing
delighted.
science in these times. That's all
Yes.
I can say.
Absolutely.
Thank you so much and a lot of good luck, and we'll be in touch.
That's good.
Thank you, everybody.
Thank you, Sharon.
Thank you.